All right. So I'd very much like to introduce our panel today. We have Myriam Merad. She's a research director and professor at CNRS, LAMSADE, here at Dauphine University. And she leads research in risk, resilience, and sustainability governance and decisions in safety, security, and health and environment. So Myriam is primarily interested in the link between science and decision, and mainly in expertise framing, regulatory and policy analysis, and participative deliberative decision analysis. Have I got that right?
Yeah, thank you.
I'd also like to introduce Nicolas Paget. He is a researcher at CIRAD, the French Agricultural Research Center for International Development, working on the uses of digital tools to support agroecology. He gave us the shortest bio of all of the participants, so we'll learn more about what he's been working on in this panel. And I also have Simon McKenzie, a lecturer at Griffith University Law School and an honorary fellow in the Law and the Future of War Research Group at the University of Queensland. His research brings doctrinal rigor together with an engagement with legal theory and more critical perspectives of international law. I also, online, have Zena Assaad, a senior research fellow within the School of Engineering at the Australian National University. She currently holds a fellowship position under the Ethics Uplift program with Trusted Autonomous Systems, exploring human-machine teaming. And last but not least, I have William Lawless, who's professor of mathematics and psychology at Paine College in Georgia, USA. His current research focuses on autonomous human-machine teams. So we have a very wide-ranging panel today. So we will explore many facets of what safety means in this context. What we've done is we've asked each of our panelists to prepare a short talk leading to a provocation. So once each of the panelists have presented, then we're going to open up the floor for discussion, both virtually here in the audience, and questions. So Myriam, would you like to go first?
Yes.
Yeah. Oh, okay. All good. On you.
So, thank you for the invitation. What I would like to share with you is some concepts on risk and safety, and then go back to element of regulation theory. So, the first discussion that I want to have with you is, what do we mean when we discuss about human and machine? So everything depends on the system we want to analyze and the kind of strata of system we want to take a look at. So there is a lot of things linked to the hardware. So the machine is a machine you are interacting with, but other kind of machine that are interconnected with machine. And the other layer is the software, and what the software can do, and what are the connections between the software you are interacting with and the other systems. But also the person who is interacting directly or indirectly with this system. And this person are also in, let's go to the other strata, in an organization with tradition, with rules to follow. And all that is in a global system with his culture, with his underlying idea and way of doing things. So when we talk about risk and safety, we want to look at some consequence of use of something that can have bad impacts. We call it negatives. And these negatives can be predictable or non-predictable in terms of impact. So we look at this system and we will try to understand what is the system that will produce this kind of harm to others, and we call it hazard. And another systems that you want to protect, let's call it stakes. And when these hazards affect this stakes system, and if the system is vulnerable, then you have an expression of risk. At a certain point, it depends also on the category of risk you want to take a look at. Is it health? Is it environment, economy, image, all that, whatever? But it depends on these different strata. And it depends what are the category of risk that will be expressed. What we call acute risk is a risk that will express itself directly. You will see it. What we call chronic risk, you will be exposed, but the expression of risk will come within the time. And there is other category of risk we can discuss on that, but we have to distinguish all these elements. And depends also what are the risks you want to take a look at, to whom, to a person, to a group, to an organization, to a territory, a society, whatever, a community, but you have also to have this kind of distinction. Accordingly, there is a set of decisions that have to be made, and to avoid certain misunderstanding and confusion about different elements of decision, we have to separate problems. The first problem is risk analysis. And in the risk analysis, we have to understand this different element of the system. And then according to the fact that you understand the risk, then you will define a set of measures that can be technical, that can be, that will affect human, meaning agent on the system, or organizational. And accordingly, since you know what is the system that will produce more risk, you will define a set of measures to act on hazard or a vulnerability or both at the same time. There is a second category of problems that will add another new problematic to handle, is how these measures will be applied and what will be the impact of these measures, I mean mitigation measures, on your system in terms of risk reduction. And then all around you have another problem that is risk communication, how to explain to some other with their different way of perceiving problem, with the different biases that you will introduce, how you will explain this dimension of risk and make people also set up this kind of mitigation measures. When risks are known, we call this principle prevention principle, because when you know something, you have to handle it. When problems became a little bit complex, meaning you are not sure what are how this risk will occur, you don't have a correlation between this exposure and this impact, then there is other principle. And these other principles sometimes are related to the precautionary principle, exoneration principle, or you have other kind of principle with a huge set of methodology that are different from the prevention principle in terms of analysis and in terms of communication and risk management. We call it resilience and risk management when we distinguish these different category of known and unknown to handle. And the way we set all the system and make the different actors interact between them, we call it governance. And then the second element that I would like to share is how we regulate the system. And my point here is not regulation in terms of text, rules, and others. It's not only that, it's how the system adapts itself, regulates itself to go to something better. So with that respect, what we have to consider is what are the elements that we want to regulate? Is it the soft, the hard, whatever? Is it the whole system? And what are the governance modalities? And I'm going to give some examples of what are the objectives that we want to obtain, what are the means that we want to invest in, what are the tools, what are the actors, and what is the organizational system, what are the contexts and the culture. So, for example, a regulation object can be human machine, but it can be also the whole socio-technical system. When it comes to governance modalities, depend on the country, depends on the context. You can have a kind of a representative democracy, meaning experts and decision maker, public decision maker are involved and citizens will follow. Or you can have delegative democracy, associative, participative, deliberative, whatever. It depends on the system and the topic. And then the tools, there is a set of tools. As I was saying, if we distinguish the problem of analysis from management and other category of problem, there is a set of tools. For example, for high-risk systems, we have a kind of tools called safety case, where we identify a set of scenarios and we try to find the right mitigation measures to handle it. Or a safety management system. There is a range and a range of tools. But depends also on the ecosystem of actors you want to involve. So do you want to have states or practitioners or industry that are involved in the process, or you want to have a large set of actors that will be involved in the process? And the means, so depends what is fixed in the regulation. In the French regulation is civilo-romaniste, the code of the codes that regulate risk. We call it the Napoleonian code, where in the Anglo-Saxon you are more based on the common law. So it's not a set of rules. It's more what you learn from events. So, and there is other constraints that we can describe, but at the end, let me go to this final point. Our main problem is whatever these methods that we have for the problems to assess what are the impact of these tools, this regulatory system, on the improvement of a situation from a T1 to T2. How we can be sure that we have improved safety, looking at the whole ecosystem. Let me finish with this sentence. What I think is the more important, and we will have the possibility to discuss, is in all domains, there is a kind of oaths, there is a kind of principle that regulate the way practitioners work. And for example, for engineers, there is Archimedean oaths that define, or you have the same thing for people in medicine that are practitioners. But there is the main principle underlying this practice is the more important, and when you add something new, you share a solution, your solution should not provide more harm than reduce risk to the others. And that is the main principle. And we will discuss about that after, because it's 5 minutes, isn't it?
Yes.
Yeah. Thank you.
Thank you very much, Myriam.
Thanks. So thanks for having me here. I'm Nicolas Paget, working on digitalization issues in agriculture in Africa. I'm sorry, I'm a little dizzy now. I think it's a change in temperature. I'll do my best. But I will be talking about things that I did during my PhD, about how to frame threats in natural resources management. So it's a little aside compared to the other talks in this conference, but let's go anyway. I don't know if you're all familiar with the classic framing in natural resources management, and you probably know about the tragedy of the commons, where actors in open access systems face many issues such as exhaustion, free riding, and pollution. So in the case of systems where people do not manage resources with homogeneous actors and well-defined boundaries, usually what we see is that people devise rules, which are called institutions, to sustain long-term use of the resources, rules about who and when people can extract resources or use the resource system, who has access, etc. This is all the basis of Ostrom's approach of governing the commons. But there are some limits to this approach. I will modestly add some inputs. First, the system boundaries may be difficult to define. We have in real life situations, many systems include several types of actors. Systems may be strongly open with very difficult boundaries to set. And there are various sensitivities to characteristics of the resource. I will explain just a little later. And even the boundaries of the actors of the resource system may vary with the subject or the topic in question. I will give the example of oyster farming, which is the one I studied during my thesis. Oyster farmers act in estuaries. Estuaries are the mouth of watersheds, so you can already imagine that the system of estuaries are not closed systems, and in these systems there are many types of actors who have various sensitivities to water quality. I here gave the different sensitivities of different types of actors. Water quality is measured through E. coli levels, and oyster farmers are very sensitive. Fishermen a little less, swimmers even less, and commercial boats don't care. They can just float over water. And if it's polluted, there's no limiting in their action. They don't feel threatened by this situation. And oyster farmers have a very limited capacity to act by themselves on water quality. They can't really filter, they can't put pesticides or anything to kill E. coli. But however, they share and act on a shared resource. So that's why I try to frame, to step aside and to frame things, natural resources management through the lens of threats, which allows to take into account more open systems. The thing is that do we really manage resources per se? Like the air around it, it's here. We all extract oxygen from it. We don't really define rules to extract air, because there is no problem about it. As long as there is no pollution, at that point, people will gather and say, "Let's we have to do something, close the ozone hole and everything." So we don't really manage resources as long as there's no problem. So when we face a threat and when we feel threatened, so unsafe to relate to the word of this topic, actors devise rules and strategies, gather, try to persuade and convince other people to act and defend the characteristic of the resource they depend on. Threats can be conceived as a trigger for collective action. When we say pollution of the air is too important, we need to do something. And threat may be collective, but also may impact a lot of types of goods, maybe impact private goods like your own oysters, or maybe water quality for everyone. And the idea was to frame threats into to categorize threats in two main dimensions, and which are very subjective by construction. The first dimension is internality. Is the threat internal or less internal? Does it come from outside or does it come from our own behavior? The second one is more the origin of the threat, even though it's always negotiable often. Is the threat Does the threat come from an environmental perspective or social perspective? I here give a few examples. Classical threats are strongly internal and social. This is free riding. And the other ones is tackled in the tragedy of the commons is exhaustion or virus, which is strongly internal and linked to more environmental dynamics. But sometimes we have other threats with weaker internality. I think about looting. You have a fishing community and you have a vessel that just takes an outside vessel that just takes all the fish. Or you can have environmental issues with upstream pollution or even climate change, which is strongly non-internal, and we have little means to act upon it. And when boundaries are clearly set and there is strong internality, people can devise rules, discuss, define strategies, and study dynamics to understand and how to cope with threats. And the other one is when systems are more open, we have more blurred boundaries. And this is much more difficult because actors need to define strategies, lobby with other types of actors, and can't really settle the problem by themselves. In Australia, I studied the case study of oyster farming. Oyster farmers were growing oysters and no specific organization, and a few water polluting events felt them feel threatened by other actors' actions, and a few champions persuaded others to form a group and elaborate environmental management systems that I show here. They admitted their own impact, but this allowed them to ally with local authorities to work on sewage management and with other farmers. So the idea was that we have these systems that are very difficult to close, and we have upstream actors and the water flows that impact oyster farming activities. And they had to do a lot of work to actually close the system and put a specific boundary around the system, being able to work with the proper actors by defining information systems. But the idea was that when people share and manage a natural resource in real settings. Usually it's in very open systems and you have to make do with other types of actors. You can't just settle the issues by yourselves. I think that the lens of threats allows understanding and triggering collective action. But if I take a more pessimistic view, maybe we only take action when the catastrophe is here, like what we can see, or maybe when the system is too big, like with climate change, it's difficult to all gather around the table. So that's it. Try to be brief.
All right, so hi everyone. As Liz said in the beginning, my name is Zena and I'm a Senior Research Fellow with the School of Engineering at the ANU, and I'm also a Fellow with the Trusted Autonomous Systems Defence Cooperative Research Centre. When I was first told about this panel, I was told that the theme was safety of human-machine collaboration. And when I was asked to participate, I was asked based on the work that I've been doing around the safety of human-machine teaming. When I talk about my research, I often get asked the question, well, what is the difference between collaboration and teaming? So I thought I would use my short time here to talk through the difference between these terms and how these differences impact safety. There's an ISO standard that defines the objectives of human-machine collaboration as combining the repetitive performance of robots with the individual skills and ability of people. Now, this definition is quite consistent with most other definitions across the literature of human-machine collaboration, describing collaborative robots as performing repetitive and deterministic tasks alongside a human, with humans often having the capacity to intervene where needed. Now, human-machine teaming does not have a universally agreed upon definition. However, the working definitions do tend to agree that teaming often involves more than one human and more than one machine working together to achieve outputs that neither the machine nor the human could deliver independently. The key distinguishing factors between these terms are firstly that human-machine collaboration is often a one-to-one dynamic, while human-machine teaming is often a many-to-many interaction. The second distinguishing factor is the capability of the machines. With collaboration, the machine is performing repetitive and deterministic tasks, implying low levels of uncertainty. For teaming, the machine capabilities are more adaptive, which leads to greater levels of uncertainty. When we think about the safety considerations of these two dynamics, we can see that there are differences in how we need to approach safety for each one. And one of those key differences is how to capture uncertainty. With human-machine collaboration, the opportunities for uncertainty are quite low. And in these situations, uncertainty would likely stem from malfunctions or the system behaving unexpectedly or not as intended. With human-machine teaming, however, the adaptive nature of the machines in that dynamic makes uncertainty a more inherent part of that broader system. And so the machine's outputs will likely not be very predictable. While arguments can be made for why predictability is an important measure of safety, the reality is that as technological capabilities progress, we will be faced with more instances of inherent uncertainty in systems. Claiming that a system meets a particular standard of predictability doesn't actually make that system safe. And there are many examples that demonstrate that complex software can be made to behave in unexpected ways under specific conditions. We need to be considering how we respond to unpredictability in a timely and safe way, rather than attempting to mandate predictability in intelligent systems that fundamentally can't meet this requirement. Perhaps we need to reevaluate different measures of safety to identify attributes that are both achievable and justifiable indications of safety. We also need to explore how we can implement more robust fail-safes for complex systems. Fail-safes designed around human operators can support the interweaving of human capacity for reasoning and judgment into the operation of more complex systems. For human-machine collaboration and human-machine teaming, humans are a fundamental part of that system. So designing safety measures around these actors does make sense. The one thing that we do need to be mindful of here, however, is that human error is prevalent and it's arguably a root cause of unpredictability in human-based systems. So we can see here that the research problem of safety for human-machine collaboration and human-machine teaming needs to encompass both the human and the machine because they're both root causes for unpredictability. So I'll end here with a provocation, and that provocation is unpredictability in complex systems, particularly those designed for collaboration or for teaming, is something that is unavoidable. So instead of designing against it, how can we design around it and capture it robustly to ensure safety?
Thank you very much, Zena. Thank you to Lauren and Alexis and everyone else who figured out how to get the screens to come back on. Given that they are back on, I might invite Bill to go next, just while we have them. So Bill, you are welcome to take the floor.
Great. Well, it's a pleasure to be with you guys, at least virtually. It's still very dark here. And my body doesn't function quite as well at 5 o'clock in the morning as it does when the sun is up. So I will try. That's the best joke I can come up with this morning. I changed the title ever so slightly. Autonomous human-machine teams reality constrains rationality, in particular belief logics, but hides data dependency. So that's what my talk is about. This is only an introduction, so I'm not going to get into the details that much. So here is slide number 2. Can you see that all right?
Yep, we can.
Great. All right. Here's what our team has done. We've published 7 books. We're working on an ebook now. Liz and her student, Myriam, have published in our call on Frontiers of Physics, and hopefully we can turn that into a book, but she is online. And I just briefly mentioned that our book in 2020 by Elsevier, Human Machine Shared Context, was nominated by Elsevier for the Information Science Book of the Year in the ASIS&T group. Backgrounds. This is the calls that our team has done. We did a special issue. The first one we did was in AI Magazine in 2019. And the focus there was around the Uber, or at least my focus was around the Uber self-driving car, which killed a pedestrian in 2018. The bottom line is that second bullet, the car did not alert its human teammate nor ask for help, and the human was distracted. The Uber car and its operator were independent and poor team players. In fact, they were not team players at all. These are the other special calls we've got out. The one with Frontiers in Physics I just mentioned. That's the one that Liz and her graduate student Myriam are published in. She's one of the 15 that have been accepted. That one's now closed, and hopefully we'll be shifting to a book chapter. I'm sorry, an ebook soon. Closing on January the 7th is the special issue we've got with entropy, and a new one that I did want to mention. It's open until February the 1st for publications. Now the conference is not going to be held until July the 20th to 24th, but we want to get the abstracts in and the paper, the short papers for the proceedings. We want to get that done by February the 1st. If anyone is interested, I do consider self-nominations a viable approach to addressing some of these problems. And so please let me know if you're interested in participating. But this is going to be on data dependency, which is something that not very many people think about, but that's the critical ingredient in a team. AI safety. I read yesterday's newspaper with interest. It was about FTX, the collapse of FTX, which apparently had a profound impact on AI safety of all things. Look at the lead sentence, in which I've quoted in April, the San Francisco artificial intelligence lab called Anthropic raised $580 million for research involving AI safety. The second bullet is also quoted. The investment is part of a quiet and quixotic effort to explore and mitigate the dangers of AI, which many in Mr. Bankman-Fried's circle believe could eventually destroy the world and damage humanity. Over the past 2 years, the 30-year-old entrepreneur and his FTX colleagues funneled more than $530 million into more than 70 AI-related companies around the world. What they're working on is effective altruism. And the organizations include Google, Elon Musk, and others, and they've helped create the field called AI safety. And there's a citation at the bottom of the page for any of you who are taking photos of this. How best to control AI. This is one of the problems that I've been working on and thinking about for some time. Is it with authoritarian approaches, democracy, or a republic? And each one of those has its strong points and very, very bad points. Autonomy is coming, whether we're ready for it or not. I do a lot of work with the Navy. I'm on their AI boards, a couple of their high-level boards. And how to control autonomy is not directly a factor yet, but it's becoming, it's approaching. Overall, interdependence is a resource, in my opinion, that reflects the dependencies of team members, partners, leaders, and the power of even larger teams. Interdependence places authoritarians, that's gangs, command decision systems, consensus seekers, communists, kings, sole rulers, at a disadvantage when using rational belief logics. I think that the way that we can control these systems best is with checks and balances. And why we should ask, do minority control systems persist? A minority control system is an authoritarian system with the forcible suppression of interdependence, which is the only way that they can operate. When it places their control, their system, at a competitive disadvantage. Here's my provocation. Liz asked me to come up with one. The National Academy of Sciences report, which was published in December and is available online. You do not have to pay for it. You can download it for free. On human machine teams stated without a citation that the performance of a team is not decomposable to or an aggregation of individual performances. Now, for me, that's like music. It's like an undiscovered piece of music that I'm certain for the first time hearing from someone else. That's what my research is all about. This is something that the Academy liked, but they did not cite it, which means they could not explain it. That's something that we need to address, and that's what my new call is for AHFE. What is AHFE? That's the Applied Human Factors and Ergonomics Conference coming up in San Francisco next summer.
Thank you very much, Bill. We can send around some information on that. We're just running short on time, so I might leave that problem. Is that all right? And I wanted to make sure.
That's where I'm stopping.
Thank you very much. All right. So Simon, yep. We'll move. We can move. Switch. Okay, Bill, is it all right if I ask you to stop sharing your slides now? I'm just going to bring up Simon's slides.
Oh, I don't have any slides.
Oh, you don't have any
So,
slides. Okay,
yeah,
that's
that's
awesome.
easy.
Okay. Let's see.
Excellent. So everyone can see me on
Thanks.
screen. Excellent.
There we go.
Great. Well, thanks for the opportunity to speak here today about some of the research I've been working on. And it's a particular pleasure to speak to such an interdisciplinary crowd rather than the normal group of lawyers that I spend most of my time hanging out with. So I'm a lawyer and a legal academic, and over the last few years, my work's been looking at the legal implications of militaries using autonomous systems, mainly international legal constraints, but also dealing with domestic legal issues, which is what I'll be talking about today. So I thought a note about how we were kind of coming up with papers to write about. We would talk to defence lawyers or policy people in government and ask them what were the legal challenges that they were confronting and what might be a useful place for us to do some academic legal research to try to understand how law might apply to these novel technologies being used in novel situations. And one of the issues that kept on coming up as a key legal constraint on the use of autonomous systems by defence was workplace health and safety law. And these conversations made it clear to us that it was worth thinking more carefully about what this body of law required of the Australian Defence Force, the ADF, when they were using these new technologies, and how the use of autonomous technologies might challenge legal regime. Is everyone hear me all right? Yeah, great. I'll briefly sort of describe how Australian workplace health and safety law operates, and then I'll talk about some of the challenges. So Australian workplace health and safety law, and this is, I think, a fairly standard approach across legal regimes, is it imposes broad duties on the ADF to promote health and safety. And it does this by providing that a person conducting a business or undertaking, which includes the Defence Force, must ensure, as far as is reasonably practicable, the health and safety of workers. And it's this reasonably practicable, that's the bit that's doing the legal work here. The legislation goes on to define what amounts to a reasonably practicable measure in a non-exhaustive list, but it includes things that are reasonably able to be done, taking account of all relevant matters, taking account of things like the likelihood of harm, the degree of harm, whether a person knew or ought to have known about the risk, the availabilities of ways to minimise the risk, or the cost of minimising the harm. So some of the presentations we've heard about today have given us some ideas about how we would actually answer some of those questions. So it's a test that when we're applying it to a specific situation requires a really close and granular and contextual assessment of what a particular employer could or should do in a particular situation. And I think it's quite clear this broad principle-based approach is capable of dealing with new technologies. It's sort of so broad that I think it's not incapable. It just requires those who are deploying technology to have considered the risks to workers of using that technology and do that in a reasonable way, whatever that might mean. I think the key difficulty is, as we've heard about, is figuring out how to understand those risks. As a key part of effective WH management is assessing the risks and mitigating them. And where testing becomes very expensive, it's hard to be comprehensive about it. And where we're not used to the technologies, we don't perhaps not sure what those risks might look like. So I think it'll be harder for courts to determine what might amount to a reasonably practical measure or what risks people should be anticipating. Those developing the technology will have to think about how they articulate and explain why they've stopped testing at a particular point. You know, how much is enough, and how can the choices that have been made be explained? So there are two, I think, significant potential challenges to the regulatory regime caused by the technology. First, I think the range of reasonably practical safety measures will increase as technology increases. So a review of the Australian case law demonstrates that courts take a very fact-based approach to the operation of the test, and they really consider the specific employment context that a safety issue has arisen in. So I'll give you one case example. There's several. It's a case of May and helicopter resources, which concerned the death of a pilot in Antarctica after he fell into a crevasse returning to his helicopter. And one of the safety measures that the prosecution alleged should have been taken was that it was reasonably practicable to use satellite imagery to check if there was crevassing at the operation site, and only to proceed if there was evidence of minimal crevassing. The ACT Supreme Court found that such a measure was not reasonably practicable, and it found this on the basis that it was unclear what minimal crevassing meant. It was unclear whether the imagery, which could be many years out of date, would have actually helped. And there weren't people available to the employer who had the necessary expertise to interpret the imagery before each flight for signs of crevassing. So I think you can see in this brief example how I couldn't answer a question about whether WH law would apply in a particular way to technology in the abstract. You really have to look at the specific way it's being used in a specific context to think about what might be reasonably practicable in that measure. This brings me to the second issue, which is that the complexity of the technology will make investigating what went wrong much more complicated, expensive, and time-consuming. And legal process, one of the things, we want it to be comprehensive and accurate, but we also want it to be quick and cheap, or we want those things to be balanced. And figuring out where that balance should be struck when using these technologies is very difficult, because I think it would be bad for the legal regime if whenever something went wrong with an autonomous system, that it cost millions and millions of dollars and 10s and 20 experts to come in and tell the court what went wrong, and then for a single judge, which is how the Australian system works, to try to synthesize all that information and come up with their view of the answer. And the judge is highly unlikely to have any relevant technical training, so expecting them to be able to actually figure out what to make of the expert evidence is asking a lot of them. So I think my provocation would be, I've described the legal system, but that doesn't mean that it has to be that way. And there might be other ways that we could think about what constraints we should put around these technologies, or contexts where they just shouldn't be used. So I think we should think about how we want to allocate the risk of the use of these technologies, and thinking about how law might enable us to allocate risk in particular ways that promote the sort of objectives. So whether or not we should make it easier to hold developers accountable so they have an incentive to do more to take risk, to provide ways of addressing risk, or who that responsibility should sit with, ideally avoiding it sitting with the poor user of the technology who's told to use something and then it goes wrong. So I'll leave it there. I'm very happy to chat further and look forward to the discussion now. Thank you.
Thank you to all of you for your talks. What I want to do now is, first of all, open the floor also to via Zoom. If you want to share in chat or raise your hand, you're welcome to. But one of the things I noticed with all of your talks, you're really having to make different, you really have to think about boundaries when it comes to assessing risk or potential threats, especially when you're talking about open systems, which, are the kinds of systems that we're talking about here. So I'm wondering if you have any comments, any of you, on how you think through the act of drawing boundaries, not necessarily where you place the boundaries for a given circumstance, but how would you think about the act of deciding where to place boundaries for a certain circumstance?
Yes. Well, thank you for your question. But your question of boundaries has, let's say, two sub-questions: boundary of the system that we want to handle, and boundary of what is acceptable and unacceptable. We're raising the concept of sharing the concept of as low as reasonably applicable. Call it ALARA, as low as reasonably achievable. Is the limit where we handle a risk or we don't handle it. When it comes to systems, it depends on the context. I know in the French system, but certainly in the Australian system and others, we have a set of rules that we have to follow when it comes to, let's say, the working condition code. We have to handle all situations that can expose a worker to a certain category of risk. And we have another code that is called the Code of Environment, where everything that can have in our activity an impact on others should be handled. And then according to this coach, it defined the perimeter of what we have to consider as being the system that we have to handle. So the boundaries are, let's say, at a certain point when it comes to avoiding harm to others are defined in the coach. And then these are for modeling. And when it comes to what are the limits, depends. So if it's something that we know, and accordingly to this different coach, for example, if we know that something can happen, meaning we know we can expect it happen, meaning based on our past experience, we don't know when it will happen. We don't know exactly the location, but we know it can happen. If we know it can happen, what is applied, we call it the prevention principle. You have to handle what you know. And for this, you have to prove that you have invested the necessary means to handle this category of risk, meaning by people, methods, and tools. And it comes, the problem with this prevention principle, to what limit you have to handle it. And it's depends on system. In the French system, when it comes to a high-risk organization, you have some demonstration you have to do it. So the principle of Allah is defined with the inspection. So there is someone in an organization or outside from the organization that will check how you have demonstrated you have invested the minimum means to handle the system. When you don't know, meaning you don't have enough feedbacks that can tell you when the event will occur, or you are not able to have a kind of correlation between events and a situation, a treat or an accident incident that you want to handle, we have different principles. And there is a lot of other tools and methods that can be applied. But we have two elements. We call it the precautionary principle or exoneration principle. Precautionary, meaning you can do something even if you don't know, stop a kind of practice, or discussing about this practice according to the balance between what you will lose and what can be the impact on others. Or exoneration principle, meaning you are not responsible for something you don't know, so you're not obliged to apply that. That's we have a comment.
Yeah, for me, that's one of the most important things, like setting boundaries. Like it's like framing, like anything can be designed or thought of as a system. It's just we close boundaries and all the elements inside interact. It's like a football field. All the action is within the boundaries. But the thing is that, the way I've framed is very subjective, and it's a place for action. But it takes a lot of work to build effectively these boundaries. You can just imagine them. We should, for the questions like in oyster farming, there is theft of oysters among oyster farmers, so maybe this boundary is very little around all the fields where oysters are grown. But when it comes to water quality, boundaries are much larger. But if you decide, you're an oyster farmer, you know that the boundaries should include all the watershed actors, but it doesn't mean that the other upstream actors act within the same place and feel belonging to the same system. So it could take a lot of work setting the proper boundaries, and the limits and sizes of the system really vary on the topic. That's why I chose two different questions in oyster farming, where boundaries are very different and the way to make them work and effective are very different.
I see Zena has her hand up. Do you want to go ahead?
Yeah, I just want to say I agree with what my panelists have said and what my fellow panelists have said. The only thing I'll add as well is on that last point, when we're distinguishing between the boundary of the system versus the boundary of what is and is not acceptable, if I'm just going to focus on the boundary of the system, one of the interesting things about working with more complex systems, particularly in a military space, is how far you extend those boundaries across the life cycle of the system. And so that includes, who the designers were, who the manufacturers were, And the reason from a military perspective that those are included in the system from a safety perspective is around security, particularly around security of the systems and then security of how they're used. So I think it's a really interesting point to consider how far you push the boundaries depending on the context. I think in most civil applications, you may not have to push them as far back through a life cycle, but definitely for more military-based applications, we do look further ahead in the life cycle when we are considering the boundaries of this system, particularly from a safety perspective.
Yeah, it's such an interesting way to think about like what are the boundaries and how is law drawing boundaries, and I think in this regime that I described, the key thing is this idea of reasonably practicable safety measures, and that's the sort of boundary when you're required to act. And I think what I would want to emphasize is how it's a value, it's a political judgment. What's a reasonably practical measure? So I think it sort of demonstrates the importance of doing sort of the intersectional approaches that Caitlin was talking about before, where you're not just relying on one group of people to tell you what risks are relevant or what might be reasonably practical. Because if you looked at workplace health and safety law across many countries over the last 50 years, measures that would have seemed like wildly unnecessarily protective in the 1950s would be unimaginable to go without now. So I think it's a place of contestation, and as the sort of scientists and engineers, I'd encourage you to sort of get involved in the contestation of thinking about what might be reasonably practicable to help people figure out how to protect users or people who are affected by the systems.
Well, did you want to have a comment on this one? We've got about 3 minutes left.
Yes. Simon's comment earlier about specific context, and then your comment about boundaries. One of the things that we try to do as humans is to build boundaries, to limit the context so that we can approach it. In fact, when you have two attorneys, a defense attorney and an opposing prosecutor, they're trying to determine the context for judges or juries. When you have a football field, as Nicolas pointed out, you're setting the context and you're setting the rules inside of a particular context. If you're dealing with open systems, and that's one of the areas that I focus on, there is often an uncertain context. And so you have to do what you can to resolve that. Last year in the Department of Defense, the American Department of Defense's withdrawal from Afghanistan, they fired a drone and created a tragedy because the system of some 30 people and artificial intelligence in play made a very poor and tragic decision. And they concluded that one of the things that they should do in the future in high-risk situations is to have a red team to challenge whatever the decision is. And I think that's one of the ways that we can go forward, is to look at how to challenge our decisions as we go into open environments and how to create safer boundaries.
All right, thank you very much, Bill. We're basically out of time. So what I might suggest is, because we've got the art exhibit going on, I might suggest that we thank the panelists very much and follow up any conversations that we just covered, either via email or in person over Teams. Thank you. Thank you all. Thank you so much.